What's going on, guys? Hope everybody's having a good Tuesday so far. In this video, we're going to be making this treasure chest effect. Now, really quickly, this is not the same treasure chest from the last video. So in the last video, we made a treasure chest as well, but the treasure chest that we had before had too much details. Let me just move it down or something. So the treasure chest from before, you can see that like adding all of these little tiny details, it looks really good in Blender. I'll put that up on the screen now, but in Unity, it doesn't look as good because you don't see that detail, not the same as like in Blender. So having a more simple model is better in Unity, I think. So I'm going to be posting the entire project in the description of the video for free, so you're welcome to download it the way that it is now. And I'll also be posting this treasure chest that I made in the description of the video. Okay, so let's just actually pause. Let's go hit that chest and we'll pause the game and I'll describe what's happening here. So no, I missed it. Here we go. So you can see that the treasure chest is becoming transparent. So a lot of this is done inside of a script, a C# script, and we're going to be going over the script. So like all the parts of the treasure chest are becoming transparent, and they're becoming yellow too. So like they lose their normal color and they become yellow. And there's obviously a bunch of coins that are coming out of this as well. And after a little bit there's a bunch of stars that come out of it as well. Most of this is done in the script, and it's pretty easy to make. So if you click on one of these simple chests, you know, I've added the default stuff like the outline, the box glider, and the rigid body so you could run into it. But then I've added this chest script that has all of like the effects inside of it. All right, so this is the script that we're using to do this. This entire script is going to be available separately in the description of the video. Again, for free. You're welcome to download it and use it in your game however you can. This will only work if you have two objects, because one of them is being sent upwards. So part of the script actually moves the object. So it's only really for this specific purpose, but you could probably change it however you want to. I'm going to explain how it works. So basically, these are the input variables. Obviously, in the start method, we're getting a list of all the materials in the children. So because there's two objects, there's this is the lid, and then this is the bottom part. Both of these objects have materials. So get components in children renderer. This will get all of the renderers in all of the children, including the subchildren of your game objects. And it will get a list of all those renderers. And then we're adding each of their materials to a list of materials called material list. So we're saving all the materials for the entire object, including all the sub objects, in a list of materials, so that way we can change the color and the transparency of all of them at the same time. So something to note, that this is actually something that you can use for a lot of stuff. Like our enemy damage script, for example, we're using the same exact thing. So when you hit an enemy, he flashes white, but in order for him to flash white, all of his objects have to flash white, like all of the materials inside of him flash white. So we did this in a bunch of other videos. Like this was used, like we've used this multiple times now. This is really, really useful. You can use this like anytime you need to change all of the materials on your object at the same time. This will fix that. I have an array up here that's actually garbage. This was the original colors. We're not changing the colors back, so we don't need to save that. I deleted all the code related to that, but that's not, we can just probably get rid of this. I don't know if I use that or not. I don't think so. So this is the main coroutine that we're using. So we're calling this from another script. So when we walk into this is when this is happening. So you need to make it public. So this is like the main thing that we're doing inside of this. So the first thing we're doing is we're setting the object color to be the flash color that we inputted, which is we're using yellow in this case. So set object color just goes through all the materials, and it tries to set the base color or the color to be this color. Now, the reason that there's multiples of these is because they're different shaders have different things that are the color. So for example, our treasure chest material. Okay, so our treasure chest material here, we're using a shader graph, like a URP lit shader graph called metal shader graph. And this is our cartoon effect. So you can see that like the materials on this are a cartoon shader graph. I'm not going to be going over the shader graph in this one, but I will show it to you briefly. So this is the shader graph, and the base color for this, like the input variable for this, we've named it color, like underscore color in this case, but there's sometimes where you've named this something else. So if you've named it something else like underscore base color, which some of the things have that in it, that's why I'm using this, right? So maybe you've named it underscore base color, or maybe there's like a Fresnel color or some other color that you want to change. So we're going through all of the objects. We're checking if there's a base color or a color. And if either of these exists, we're changing it to the color. You can't do this directly because the shader could have it named something else. So if you don't have a shader, if you're just using like the lit shader graph, it is color by default, but it's not always color. So there's a lot of cases where you've named it something else, and in order for you to edit that variable value, you need to have the actual reference name. So it's inside of the shader graph. It's this one that says reference. This is the thing that you need to edit this in the code. Okay, so after you've set the color, we're gonna wait the flash duration. Originally, I was gonna make it finish flashing before it disappeared or whatever, but that's not what I did. So we're just waiting. I have this set as 0.1 seconds. So you basically just wait like a millisecond. It's not very long. Then we are setting a variable called elapsed time to count through the fade duration. This is how long it will take for this to fade away. I think I've set it very, very low. So let's see. So the fade duration, we have this set to half a second. So over half a second, we're changing the alpha to 0 from 1. So we're taking the alpha 1, lerp just interpolates between two numbers. So the first number is the starting number and the second number is the ending number. And then this is the position, which is a number between 0 and 1. We're taking the elapsed time divided by the fade duration. So if the fade duration is half of a second, the elapsed time starts at 0. 0 divided by 0.5 is 0. So 0 is 1. And 1 is 0. So this is where this is in this. I'm not doing a great job explaining this, but yeah, so this is this is the distance between the two as the number between 0 and 1. So when elapsed time gets to the end of the fade duration, it will be 0.5 divided by 0.5. When it gets to the end, 0.5 divided by 0.5 will be 1. And 1 is this number and 0 is this number. And it interpolates. So halfway through, like when it's at 0.25, this number will be 0.5 because that's halfway between these two numbers. So this is how you can smoothly like transition between things. And then we're setting the object alpha. So this is the actual code that makes it transparent. So we're setting the alpha using this method. So every time this changes, we're using this method to actually change the alpha. We're checking the materials for alpha as a property. So let's go back to that shader graph that we're looking at. So this is the cartoon shader graph for the treasure chest. So this is what like actually makes the treasure chest look that good. This is going to be included in the description of the video for free. And at the bottom here, you can see we've plugged in a variable called alpha into the alpha of this material. And the reference for this is called underscore alpha. So hopefully that makes sense to you. So we're changing this value. 0 is completely transparent and 1 is fully transparent. Something to note is you also have to change, and you also, yeah, because the zombie, for example, uses the same shader graph, but it's unlit. Unlit materials can't be transparent, so you have to use kind of these settings for this to work. Okay, so I'm also setting these other two properties. So reflective is like the metal on the chest is reflective, and I'm just changing this value to 1. 1 is on, so it's a Boolean value. So it's like a yes or no. So I made all the materials the same reflective. They're all going to be reflective because of the way that the thing is working. And then the Fresnel strength is how strong the reflection is. I'm not going to go over that in this video because this video is about the chest visual effect, and this is a kind of a complicated topic that probably needs its own video. You could just ignore these. We're changing the outline width to 0. So the chest has a outline width and we're getting rid of the outline width. So when it's opening, you don't want to be able to see the lines around it because it takes away from the effect. This outline width, it doesn't have a color. It's generated in a completely different way, and it will be black still. So when the chest opens, having a black outline on both pieces just is kind of ugly. So I got rid of that. And then we have this else statement. So if it doesn't have any of these materials, it will warn you about it. We don't actually need that. We don't need any warnings. It just won't do anything. If it doesn't have any of these things, then it will just skip it. Okay, so moving on to the last part of the script, we've got this part of this. This is also called from the other script. So this is not called from that IEnumerator. This is a separate one that gets called, and it's called separately. So basically what this does is it moves the object upwards and it rotates it away from the direction that it started. So it's like rotating it away from the thing. So this is for the top part of the box, not the entire thing, but the top part. So we're passing in the object transform, which is like the top piece of the box. The target height is like how high it's going to fly upwards. And then the duration is how long it's going to take. So this just basically makes it go flying upwards. So it's the same thing. Remember, lerp is the exact same thing as above. Quaternion lerp is the same thing, where it's just interpolating between rotations instead of positions. So we're using a quaternion instead of a vector 3. Yeah, at the very end of this, when it's done doing that, it will set the position and the rotation to the end position, so that no matter what, it will end up at that end position. Yeah, I mean, this is pretty self-explanatory. This is just like moving the object upwards. Okay, so now we're going to go over the player movement script, because this is the script that handles actually running into the chest. So this is attached to our character. I'm using a character controller. So you might not be doing that. So you'll either use on collider it or on controller collide. It doesn't matter. So whatever your character is using for when he runs into things, this is where you're going to put this. So if I run into a coin, I handle the coin pickup. If I run into the chest, I handle the chest pickup. This is not a great way of doing this. You shouldn't use the name of the object. You should use something else. I'm going to be doing that at a later time. This is just very simple and something you'll probably already have in your game. So when I run into a chest, it will use this handle chest pickup script. So the first thing it does is I have a static class called player where I save all of the settings for my game. So inside of this player script, I have a list of integers called already picked up coins. I'm going to be renaming this because I'm reusing it. So initially this was for coins, but it's also going to be used for everything else as well. So when you pick something up, every single object in your entire game has an instance ID attached to it. And there's only one instance ID per object. So there can't be duplicates of this. It's unique to that specific object. So we're checking if we've already picked up this integer. It's a number, right? And if we haven't picked it up, we're going to add this instance ID to our list here so that we don't pick up the same object multiple times. Now, there's a lot of ways you can do this. You could add like a wait time and a Boolean, and a lot of people do that as well. But this just prevents you from double picking up the object, and you don't have to wait any time. It just does it immediately. So then we're starting our two coroutines that we went over. So this is the bottom one, the very last one that we were looking at. This moves the object upwards and rotates it. And then this is the flash and fade coroutine that we went over at the beginning of the last script. It turns it yellow and makes it go transparent. And then after these two are done, we're also instantiating the visual effect that spawns all the stars and does like the little flash. And that's what we're going to go over next. And then we're dropping the items from the chest after that as well. And so we went through dropping items, I think, in the previous zombie video. So if you watch the zombie video, you can get that. I'm not going to go over that because dropping items is a little bit complicated. We're using a scriptable object, and there's a list of possible drops, and there's like percent chance and stuff like that. I don't think there's time to go over how the drops are working. So if you want to learn how to do that, in the zombie video, I did that. So you can go and watch the zombie video if you want to. But yeah, so that will drop items from the chest. And I've added a chest multiplier. So when you kill a zombie, there's only one chance of the drop happening. But when you go run into a chest, there's 10 times more things are going to come out of the chest than the zombie. Again, this is not the final way this is going to work, because the zombie might be able to drop certain things, whereas the chest could have other things that drop, such as like larger items or specific things that are only coming out of chests and not coming out of zombies. Yeah, so the last thing we need to do is make the visual effect that actually happens. So we're calling the visual effect right here. We're instantiating this chest script stars. So inside of our chest script at the very top, you can see there's a visual effect called stars. So we've created this visual effect. Let me show you. Let's just get out of the game for right now, and I'll just drag it into the scene. Yeah, so here it is. So when we click play, so you can see that there's stars coming out of this. So you actually need to model a star for this to work. That's very, very simple to do. So you can see that I have a star model here, and I'll attach this to the description of the video for free. So if you want, you can just download my star if you want to. But in Blender, there's like, if you just right click, you can just add a star. So let me just show you. So inside of Blender, if you, sorry, not right click, Shift A to add an object, mesh, and then extras, there's something called the simple star that literally will just immediately make a star. All the settings for this are at the bottom, so you can make it a little bit thinner because that star is like too big. And then you're also going to want to bevel it so the edges are rounded. So if you press tab on your keyboard, you can press Control B and you can drag this away a little bit and scroll up on your mouse wheel so that it's more like subdivided. And then you press tab to go back into object mode and shade it smooth. And this is how I made this star. Now it's important to note you're applying a shader to this inside of Unity, so it will have like a very glowy specific effect to it. So you don't need to worry about like the materials or like the color or like the it's not going to be a lit material that we're using. So all these lines that you see on this are not going to be visible because the star is like completely unlit. So it's not affected by lighting, and these little lines are caused by the lighting. But yeah, anyway, that's how I made it. It will just be attached in the description of the video. You're welcome to download it and just use it. But if we play this and pause it, you can see like these stars, like the lines and stuff, they're not visible because this is not affected by, oh, I do have lighting on it. But anyway, you can't see it in the game view. It just looks like pure yellow. So I'm going to go over the visual effect now. This is pretty basic standard visual effect. So the first things first, to create a visual effect, you need to make sure you have the visual effect graph enabled. So if you go to the window at the top, you can click Window, Package Manager, and then make sure you change this to Unity Registry, and you could just type in visual. One of the options will be the visual effect graph. And then if this says install here, you'll just click install and that will install it into your project. And then if you right click at the bottom, you can click create visual effects, visual effect graph, and then you can rename it to anything you want. Inside of the chess script, we've named it stars, but you just drag the visual effect into this slot. That's how that's working. So this is the visual effect graph. And there's two parts to it, okay? So there's the part that makes this flashy light thing, and then there's the part that actually shoots the stars everywhere. So let me just see which is which. Hang on. Yeah, so this one on the left, this is the star one, and then this one on the right, this is the actual flash. Let's go through the flash first, because this is something that you can do by default when you start. So when you open this for the first time, it will already have one of these graphs set up. So all you really need to do is change this. So this starts out as constant spawn rate. So you'll delete the one that's here, and you can press space bar and type in burst, and you'll add a single burst. This only needs to be 15 particles. You could change the capacity to 15 to match that. So because there's only ever, this is just going to flash and it's going to disappear forever, right? So you don't need more than that. We're setting the size to something massive. We're setting the angle to be a random angle between 360 and 0. So if any of these things are missing in yours, you just press space and you can just type in the name of the thing that you see. So this would just be set angle. If you click on it, there's like a random option. All the options for it are available if you click on it and look in the inspector on the right. So we've turned random on for this. So if you add set angle, it won't have a random. So you just need to change that in the thing. We're setting the lifetime to be 0.3. I think this starts as a random between two numbers. You can turn the random off the same way that you turn it on. So inside the inspector, when you click on it, you can turn the random off. We're not doing anything in the update particle. And then we're outputting a quad. So a quad is just a small rectangle that only faces one direction. So it doesn't have the backside of it. And this is just like a picture. We're using the default particle, which is available in all of your projects by default. So this is the same particle from the particle system. So we're just using, I think we use the top one here, and you can see that it's 45 in size, which is kind of massive. And then we're setting the color over life to be a gradient. So the top numbers of this are the alpha and the bottom is the color. So the very last key, the alpha will be 0. The very first key, the alpha will be max. This means that this particle will fade over time. So it starts out full opacity, and then over the duration of this particle, it will become 0. So it will fade away as it's going. And then this is the same thing that we did. So this is the star one. So to duplicate this, if you take the whole thing and you press Control C, you can press Control V and you can make another copy of it. So that's what I did. So I made the star one first and then I copied it and changed it after. But you can make a copy of it like that. And all of these will happen on the start of like when you run the visual effect, all of these little graph things will happen. So this is the star one. So we're also doing 15 stars. When we initialize the particle, we're setting the size to 3. This is significantly smaller. So if you copy, make sure you change this to lower. We're setting the velocity to a random. So the x-axis is like left and right. So it's -30 to 30. So it could be any number between 30 and -30. So like that's horizontal, right? Then the same thing for the Z axis, which is like forward and backward. But the Y axis, we're only doing a number between 0 and 45. So this is upwards. So we don't want any of the stars to go directly downwards. We want all of them to go upwards towards the camera. So the higher this number is, the higher the stars will fly upwards. We're setting the angle of the star to be the exact same as the particle. So the main difference between these two, so we set the lifetime random here. So the stars are a random number between 1 and 3. Again, you change the random over here on the right, so you can enable it. And they'll all be a number between 1 and 3. This should actually be per component probably. And then this is the only part that's really different. So at the very bottom, instead of using an output particle quad, we're using an output particle lit mesh. So if you delete it, like if you click on this, you can delete the entire thing. And if you drag from this over here, you get all the possible things that you can output. We're just using this URP lit mesh. And we're getting a shader in this for the color. So let me delete this one. So this shader you just have to right click at the bottom and hit create shader graph, URP lit shader graph. That's what we've done here. And if we double click on the shader, in the settings for the shader, you need to turn on support VFX graph. If you don't see this option, if you go to edit preferences, in the visual effects setting, you can turn on experimental operators and blocks. If you don't turn this on, this option will not appear. And yeah, you kind of need this option to control the colors. If you don't have this, it's a lot harder to control the colors. We're going to turn that on. So supports VFX graph. And then the rest of the settings don't really matter. So this is the shader graph. Let me just bring it out and I'll close these things. So it's just a UV into the time node of a sample gradient. So inside of the shader graph, you can just create a node. You can type in gradient and you can add a gradient. Inside of the gradient, you can change the colors to be whatever you want them to be. You can see that mine's yellow, but this middle key is the intensity is turned up, which is like the glowiness. And so the gradient itself can't go directly into the color. It can go only into a sample gradient. And the sample gradient is affected. Like if you have to put a UV node with a time so that it goes into all of it. It's also important that the sample gradient goes into the base color and the emission. If you don't put it into the emission, it won't glow. It will just be the color that it is. So let's save that. And I get the most important takeaway from this again is that you have to turn on supports VFX graph. If you don't turn this on, you won't be able to do this. And when you go to look this up in the output particle lit mesh, it won't show up unless you've enabled that. So in the shader graph at the top here, if you click this, all of the shaders that you've enabled that setting will show up. And then you just need to select the shader that you've made, which again is just a gradient. And then lastly, we're multiplying the size over life. So it starts at the full size and it shrinks over the lifetime of the particle. So if we run this again, you can see that the stars are shrinking as they're going away from the center. So they kind of just shrink as they're disappearing. And this is important that this is multiply size over life. So again, to add a block, you just press spacebar on the thing and you could type in size over life. And you need to choose multiply size over life. Or if you added size over life, you can click on it. And at the top right, the composition could be multiply. If you have this set to overwrite, any size that you set up here will not take effect at all. It will just be overwritten by whatever the value is. But yeah, so this is the entire shader in the entire visual effect that we've made. It's very, very simple. It's just a burst of particles. You could also use a particle system for this. You should only really use the particle system when you're using the physics. So if the stars were to do damage or to bounce off of things, like if you didn't want them to just fade away and disappear, like if you wanted them to hit the floor and bounce off the floor and stuff, you could use a particle system for that. The visual effect graph has the advantage of being calculated on your video card instead of the CPU, and your video card can spawn a lot more particles at once without causing any performance issues at all. So this is the superior performance way of doing this. But again, if you want it to interact with your scene, you need to do it in the particle system. So that's pretty much going to be it for the day. I hope you guys enjoyed my video. If you did, make sure you like the video and subscribe to the channel. The thing that we're going to do in the next video is actually really cool. Hopefully I'll get the room. So I've created, let me just turn off these chests. They're just in the main area. They should be in a room in the actual final game. I recently added this pixelation shader to the game. This is something we're going to probably be doing in the next video, maybe tomorrow or whenever I get around to it. So I've created a new room that has holes in the ground. And when you fall through the holes, you can see that the character gets all pixelated, and then as you spawn in the middle of the room wherever you fell off, it depixelizes. So this is going to be a really awesome next video. I hope you guys are excited for that. Anyway, if you guys enjoyed the video, make sure you like the video and subscribe to the channel. And yeah.